In order to charge an electric vehicle, you need a power cord for it, just like you would need to charge your cell phone. In the case of an electric car, it's called an EVSE, or electric vehicle supply equipment. In Tesla's world, they call it a mobile connector. Others tend to just call it the charger, or maybe sometimes they'll call it a mobile charger. In any case, it's a method of plugging your car into an electrical source. The key difference with an EVSE is that it has electronics built into it where it's communicating with the car and it's checking the electricity from the source and is making sure that everything is flowing into the car safely. And it's making sure that the car isn't pulling too much electricity from the power source. Some things that are important to consider is, of course, the plug configurations at either end of it. There are a lot of different electrical pin configurations of different outlet types in the United States and in the world, so you need to make sure to get one that has that pin configuration for the outlets that you have available in your house or place of business or wherever it is that you're plugging in to charge. And at the other end of it, then you need to make sure it will plug into your car. If you have a Tesla, then you need a North American Charging Standard Tesla type plug, or it might be J1772, and potentially you could have a J1772 EVSE that you then have an adapter that plugs it in to a Tesla. So there are various options. In fact, there are adapters at the other end of a mobile connector as well. You can use to take a NEMA 1450 plug, for instance, and adapt it to a NEMA 1430 plug, which would be more like a dryer outlet. I carry an EVSE in my car just all the time, just in case we need to charge in an emergency. However, after 4 years plus and 66,000 miles plus, we've never needed to charge the car in an unplanned situation. I have used my EVSE many times on road trips, and let's be honest, oftentimes we forget things when we're going on trips, so it's a good idea just to keep it in the car at all times so that when I am on those road trips, I don't need to worry about the fact of maybe leaving it at home and becoming stranded, or just having to rely on superchargers on the entire trip. It is very convenient to be able to charge from varied sources while on road trips. When I began going on road trips in my Tesla back in 2019, I quickly discovered that at a lot of friends and family's homes that we were visiting and charging from, their high-powered 240 volt outlets were not accessible with the length of the mobile connector that the Tesla has. And so I found that if I combined it with the 50 amp extension cord that's meant for RVs, then also I can use different adapters on that, and I can charge my car from all kinds of sources, and I've done so many times through the years. And I'll put a card above that outlines that charging solution in more detail. Over the years, I've evaluated and tested various EVSEs from multiple manufacturers, such as Juicebox, Electron, MeGear, and now ShockFlo has sent me their G1 EVSE to test and review. This unit can handle up to 40 amps, which is great because many EVSEs only support up to 32 amps. And that difference of 8 amps can make quite a bit of a difference if you're trying to charge all night long and you need to charge from empty. You sometimes need that difference to be able to get it full by the morning. This is the ShockFlo EVSE that they've sent to me, and so you can see here it handles up to 40 amps. And I just wanted to go over a couple of key features down here. So it has amp adjustability at these different intervals, and maximum it can handle 9.6 amps, which is the 40 amps at 240 volts. And it has the hardwired NEMA 1450 plug, and then also it is IP67 waterproof. And then the cord is 20 feet long. As a point of comparison though, you can see here that the Tesla mobile connector is also 20 feet long, and it only handles up to 32 amps with the Gen 2 mobile connector, which is the one that they're selling right now. And lastly, it is 10.43 pounds. So let me now show you what comes with their package, what they send, and in the ShockFlo unit, and then we'll test it out. The mobile connector comes in this very nice zipper case, and this case was inside of a cardboard box, which I took it out of already. And the devices inside, the parts of it, are packed in some bubble wrap here. The connector here with the cover removed, you can see is the J1772 pin configuration. And then it has the typical locking configuration here with the lever that stops the charging when you push this button down. And it has a hole right there that you can put a lock through it to lock it to your car if you wanted to. And it has some information here on the bottom. And the cable itself has a nice rubberized texture to it. And it's not a thin cable by any stretch, but I have seen some that are thicker, so this is not too bad. As a point of reference, this right here is the ShockFlo connector. This is the J1772N. This is the Tesla mobile connector that comes from Tesla. This is the Gen 1, but the Gen 2's handles look the same. You can see it's definitely bulkier, so Tesla has always been the best at that. And then look over here at the cable ends. So this is the ShockFlo cable, and this is the Tesla cable. And there's a noticeable difference in thickness. And the cord is definitely more supple. ShockFlo is thicker. So that being said, this is normal. This is what most of them are. I have several and they're like this, except for Tesla is the one that's really amazingly thin and supple. It's also interesting looking over here at the base unit. This is the ShockFlo unit compared to the Tesla mobile connector. And look at the size, like pretty significant size difference there as well. Moving on to other parts in here, we've got the other end of the connector, and I'll take the cover off now. And this is the NEMA 1450 pin configuration. Now, one thing that is a key differentiator with this ShockFlo mobile connector is that this is not a removable plug end. It doesn't have any other plug ends. This is all that it is NEMA 1450. This is the Gen 1 adapter like I talked about before. So this right here, there's a button you can press and the adapter comes off. This is the NEMA 1450 adapter. And Tesla sells this with several different connections so you can put on different plugs, whereas ShockFlo just has the NEMA 1450 and it's not changeable. Now that's not a big deal in my case since I use a variety of other third-party adapters, which I'll outline in a video that I'll put a card above to it, and it all links back to the NEMA 1450. So if I'm going to have one connection type, this is going to be it. This is what I want. It does come with this right here, which is a wall hanging bracket. It comes with the necessary screws and drywall anchors. This is the wall hanger right here. So it just, this base unit right here slips into this when it's on the wall. So this is the main ShockFlo unit here, and it has an LCD screen on there, which is new and unique. I haven't reviewed one with that yet. And it has two buttons here, one for adjusting the current and one for delaying the charge time. And then it has an indicator light bar here. Here on the back, it has information about the mobile connector and the specifications of it. So I'm going to plug this into the wall now and we'll see this light up, and then we'll plug it into the car and start it charging. This is my NEMA 1450 I installed here in my garage. So I'm going to go ahead and plug in the ShockFlo mobile connector there, and it already lit up here. So now it's showing that it can go up to 40 amps, and then it has the amount of kilowatt hours it has output, which right now is almost nothing. It should be 0, but I'm wondering if maybe they did a little bit of testing before they shipped it. It's showing the temperature, which is potentially a useful thing to see. So 30 Celsius right now. 238 volts is what it's getting. And of course it's outputting 0 amps and kilowatts, and then it's going to show the charge time here. And it's showing that it's ready. Now if I push this current button, you'll see that it jumps from 40 amps down to 16. And then we can hit it again. It goes to 20, 24, 32, 40. Now, I would say, if it were me, I would prefer that this would adjust at 1 amp increments, because there are varied situations where maybe I'd want to have a little bit more fine-tuning adjustment. But the idea behind these is that 40 amps is the amount of charging that you want to charge when you are on a 50 amp circuit, because it's the 80% rule that you're not supposed to charge continuously for over 3 hours on an 80% of the circuit's maximum. So to go back to the bottom, 16 amps, that would be for a 20 amp circuit, 20 would be for a 24 amp circuit, 24 would be for a 30 amp circuit, 32 would be for a 40 amp circuit. So that's the idea behind these quantities. I'm going to go ahead and leave it on 40 since I'm on a 50 amp circuit here. And then the time delay down here, I can go ahead and push that. You'll see what it looks like up here. And it looks like you can see it's adding right over here. It's just putting on a time delay in 1 hour increments. And looks like it maxes out at 12. And if you go past 12, it just drops off, and so it's gone completely. So the time delay is off. So let's go plug this into the car now. Now regarding cable length, this is 6 meters or 20 feet long. And you can see, I've got a couple of things here on the shelf, but the cable comes along this way. And don't mind all the other cables, this is all my other testing of other things that I'm doing. But this cable comes down here, and I've got it going underneath the back of the car and up around over here. So it's a little on the short side. I mean, it's obviously working, but some additional length would be helpful. You can see most of my other connectors that I'm testing have 25-foot long cables. And you can see these cables here, they're coming up, and I have them running on this metal rail that is coming across over this way. This is a 20-foot long metal pole that I cut to length, and it It spans the garage. As you can see, it's bracketed right there. I made a video about this, and I'll put a card above to that video. But you can see I've got a variety of mobile connectors here I'm testing. I've got these in other videos that I've either done in the past or I'll be doing in the future. So in any case, I can't put that one on that metal bar because it's too short. And right now it's kind of a temporary setup. Anyway, so just keep that in mind. Make sure that 20 feet is long enough. Now in my case, because I have a Tesla Model S, I have the North American standard connection or Tesla configuration right there. And so I need to use the J1772 to Tesla adapter. And this comes with all Teslas. And I've also reviewed a couple of third-party adapters on my channel. And so I'm going to go ahead and put this onto the ShockFlo mobile connector and then plug this into the car. Okay, there we have it. It's charging just fine. So now let's look in the Tesla and see what the stats look like. Here in the Tesla, you can see that I've run the battery down to 6%. I wanted to do a test of testing the mobile connector, this ShockFlo connector, to see how hot it gets when it's been charging for a while. You'll see it's currently 91 degrees as an ambient temperature. So right now it's pulling only 10 amps, and that's because I have manually configured the Tesla to just pull that, because normally I'm charging this off of our RV, and I adjust it up to 20 amps on the RV or down to 5. It just depends on the circumstances. I'll put a card above to that video of how I charge my Tesla from the RV. So right now though, I'm gonna go ahead and come over here and increase the amps all the way up to 40. And so now it's going to do that. So we can look over here, we can see the amps are adjusting upward. It always takes a few moments for it to do that, as it just slowly adjusts and watches the voltage to make sure it doesn't blow any circuits right away. The voltage is dropping a bit. It's down to 232 volts right now. You can see that right here. And now it is up to 40 amps. And so we're at 232. So it's estimating that the car would take 8 hours and 15 minutes, and it's actually still declining, in order to get to the set point. And right now we have the Tesla set to go up to 90%. And so it's estimating 7 hours and 15 minutes. I'm going to go ahead and let the Tesla continue to charge for the next several hours. And then I'm going to come back out once the mobile connector has had a chance to get good and hot, and we'll check the temperature of it with my thermal imaging camera and see how it's faring. The car has now been charging for 3 hours and 55 minutes. So let's check the temperatures of the cord, but first I just wanted to show you the state of the charge of the car. You can see here the battery's up to 52% now, and it's 91 degrees here in the garage where the car is. We're still getting 9 kilowatts, it's still charging at 40 amps, and we're at 235 volts now. Over here at the ShockFlo base unit, it has the green indicator here showing that it's charging. And then if we zoom in here on the LCD display, it's been charging for 4 hours now, and it's at 236 volts. It's showing 39 amps here. I'm not really sure. I've found that with these devices, usually they derate them just a tiny bit from what they state. And so it's getting 9.3 kilowatts into the car right now, and it's now past 35.95 kilowatt hours into the car. So basically 36 kilowatt hours have been transferred into the car through this unit, and it is 62 degrees Celsius. Starting with the thermal imaging camera over here at the NEMA 1450 plug end, you can see that the plug receptacle just past the plug is 124 degrees, and the plug of the ShockFlo mobile connector is 117 degrees. And then if we move up to the cord just above that, it's 130 to 133 degrees. So that's pretty warm. And then if we move around over here, it's 127, 126, 132. So that cord along there is pretty warm. And then we get here to the base unit. The cord coming into that is 139, 140 degrees. That's quite warm. If I put my hand on that, it definitely feels quite warm. Not too hot to touch or hold your hand on, but it's warm. The ambient temperature here in my garage right now is 89 degrees, keep in mind. So that's just as a point of reference. As we move down here onto the device, it's 110 degrees there, and 120, 112, moving along down the device. Now if I flip the ShockFlo device over you'll see the back side is where all the heat is. It's much warmer right here in the center area, and if I put my thumb on there, it's actually hot enough that it's almost more than I can bear. So if I move my thumb away, you'll see there that 172, that's the peak that I've seen. I mean, for what it's worth, this plastic isn't melted. I'm going to continue to use this mobile connector, and I'll put a pinned comment below this video if there's some update to mention. As we come here on the cord coming out of the back of it, it's 125 degrees, and then we get to the cord and it's 134. It stays probably around 100, looks like 117 to 120 or thereabouts all the way along the cord. And I'm just going to point it quickly. You can see it goes over the edge of the motorized couch there and goes down onto the floor. This is now the cord on the other side of the couch. You can see it's still about 120 degrees here. There you can see it coming around under the car, and it's still about 100 degrees coming along this way. And then right here, as it's coming into the base handle of the J1772 connector, it's about 118 degrees, and then about 103 degrees, so the handle is quite cool. 102 degrees, so that's not too bad at all. And then this is the J1772 adapter right here, so that's not the ShockFlo connector. But here at the handle, it's actually much cooler. My final thoughts on the ShockFlo mobile connector would be, here's some pros and some cons. The pros would be, I like that it has the LCD screen on it showing useful information. I like that it has on-device buttons that you can use to change the amps. And then also, I like that it can handle up to 40 amps because that's a useful speed. 32 is just not quite fast enough in some situations. And then also I really like that it's waterproof because obviously you're going to be using this thing outdoors sometimes, like if you're charging at a campground pedestal, electrical pedestal, you need to have it be waterproof. Some of the cons would be, I don't love that you can't change out the connection point on it, like natively. The length of the cord being 20 feet is the same as the Tesla mobile connector, but it is shorter than some of the others that I've tested that are up to 25 feet. So that might be a consideration, but if you combine it with the 30-foot extension cord like I do with RV, that is from the RV industry, it's for 50 amps, so it's plenty robust enough, then that is not a concern, the length, because that will make it plenty long. It gets quite hot. I mean, I've tested other mobile connectors and used my FLIR camera on them as well, and they didn't get quite this hot. If it's designed for that heat though, then that's not a problem. And as I was using it, it didn't melt or anything. So there's not a problem. The ambient temperatures were around 91 degrees the whole time. So that's a consideration, but it gets hotter in some places in the United States. So that's one thing that I noticed. Overall, I would say this is a good mobile connector, seems to be good quality, and I will continue to use it. And if I discover any flaws or if there's any problems that I have with it, I will post a pinned comment below this video to let you know what happened. If you're interested in purchasing this mobile connector, there is a 10% off discount code in the description below. And with that, thanks for watching, and I will see you in the next video.